Woohoo! It's a great day to be in geometry. I'm Miss Lake Battles, and I'm here today to talk to you about circles and arcs. First of all, you need to know that there are two different numbers associated with an arc, and I have the arc highlighted in green. Those two numbers are one, the arc measure, which is measured in degrees, and notice it is the exact same number as the central angle measure, that's in black. And the other number is the arc length, which is measured in a linear unit. So I made up values for this problem just so you could see. The arc measure is 85 degrees and the arc length is 3 inches. In our study of circles, you'll often be asked just to leave the answer in terms of pi. That means pi will be in our final answer. In short, just do not put pi in your calculator, because when you do that, your calculator will make an approximation for pi and substitute that in for pi. So leaving it in terms of pi means there is a pi in the final answer, and this is an exact answer, not a rounded off answer. Next, we're going to look at some important formulas for circles. The first formula is for circumference. And if you know the circle song, if you need a circumference, just use pi d. And we're also going to talk about arc length. So notice in my second circle, there is an arc length. I have the arc outlined in green. And we can find that arc length by finding what fraction of the circle the x degrees represents, so that's going to be x over 360, and multiply that by the circumference. So in other words, arc length is just part of the circumference. Then we have area of a circle. Remember, pi r squared sounds like area to me. And then for this last diagram, that's area of a sector. And we learned that a sector is shaped like a slice of pizza, and that degree measure, x, divided by 360 will tell us the fraction of the area of the circle, and we just multiply it by the area of the entire circle. Like if we knew the area of the whole circle and only a fourth of it was shaded, we'd just take a fourth of that area. Let's look at some examples. First of all, let's find the measure of arc TDC. Now remember, if it's labeled with 3 letters, it's a major arc, which means it is larger than a semicircle. So I have TDC outlined in yellow. So remember, the arc measure is the same as the central angle measure. So this arc measure is 127 degrees. Okay, now together these form a linear pair, so that's 53 degrees. And of course, we know that the semicircle is going to be it's going to be 180. So the 127 plus a 53 there, that's going to give me that 180. This one is 90. So notice that these two together form a linear pair. You know, this is 90 also, so this one's going to be 90. So it's very easy to find the measure, we'll put a little m in front of it, of arc TDC. The measure of arc TDC, you could do it one of two ways. It is everything but that 127. So you could say that it's 360 minus the 127, and that's going to give you 233 degrees. Or you could add up the ones that make up that arc TDC. That would be measure of arc TDC would be equal to, add those up, 90 plus 90 plus 53. And notice that's going to give us the very same answer. So that's just two different ways of coming up with that arc measure. Now, number 6 just says that we're supposed to be finding the circumference of this circle, and we're going to leave the answer in terms of pi. So my formula for circumference is pi d. Okay, remember d stands for the diameter. So you could also use 2 pi r, that's fine, because if you multiply the 2 times the radius together, that's the same as the diameter. So in this case, the diameter is 18 centimeters because the radius is 9, so the diameter would be all the way across. And so it says leave it in terms of pi, so that's really all I do. It's standard to put the 18 first. It's 18 pi, and this is centimeters. These next two problems ask us to find the length of the red arc, and we're going to write that exact answer, which means it's in terms of pi. So to find the arc length, let's recall what our formula is. Arc length, we're going to take the measure of that arc in degrees, and we're going to divide it by 360, and then we're going to multiply it by the entire circumference, which is pi d. So let's make our substitutions. X degrees, that is 30 degrees in this problem. 30 over 360 times pi times the diameter. Now the radius is 9, so notice the diameter is going to be 18 centimeters. So that's pi times 18. Now my fraction reduces easily that by a factor of 10, and then that's just going to be 1/12. So this part of the circle, this arc, is 1/12 of the whole circle. And the whole circle has circumference 18 pi. So what is 1/12 of 18 pi? Well, I would just simplify here. You know, this has a common factor of 6. 6 goes into 12 2 times. 6 goes into 18 3 times. So that's just going to leave us with 3 pi over 2. So we're supposed to have this exact answer. So this is my exact answer form. And of course, it's a linear measure, so it's going to be in centimeters. Okay, next, I'm going to find arc length again. So remember, arc length, I'm going to write my formula down, is x degrees, that's my arc measure, over 360 degrees times pi d. So for this problem, I have to find this arc measure. Well, if this one is 120, then this one's going to be 60. Notice that together they make a semicircle, okay? Just like these two angles form a linear pair. It's the same thing. So for this one, that's 180 minus 120. That's how we get this 60 right here. So 60 over 360, hey, I know what that is. That's just 1/6 of the circle, okay? That's just going to reduce to 1/6. Anytime you have a fraction and you're not sure about what it would reduce to, you can always use your calculator for that. Just enter it as a fraction. Now, for this problem, the diameter is given. It is given to be 54. So I want 1/6 of the whole circumference, which is 64 pi. So 1/6 of 54 is 9. So I'm going to get 9 pi, and this is going to be measured in feet. So 9 pi feet, that's my final answer there. Next, I have this great application problem. It says a 2-foot wide circular track for a camera dolly is set up for a movie scene. You know, if you want to, you can look in your text. They have a diagram of this. The two rails of the track form concentric circles. That just means they're circles in the same plane with the same center. The radius of the inner circle is 64 feet. How much further does a wheel on the outer rail travel than a wheel on the inner rail of the track in one term? So really, they're just asking us for the difference between the circumference of the outer rail and the circumference of the inner rail. See right here, how much further? How much further? we are going to subtract to find the difference. So here we go. Let's find the circumference of the outer rail and subtract, and we'll color code this here. That'll help. We'll subtract the circumference of the inner rail. Okay, now remember, how do we find circumference? If I need a circumference, I'll just use pi d. So that's the formula that I'll be using for both of these. So first of all, let's find the diameter of the outer rail. Okay, the diameter of the outer rail is going to be, well, if it's 64 feet from the center, to the inside of that outer rail, then we're going to add another 2 feet. So if the radius is 66, then we're going to have to multiply the radius times 2 to get the diameter. So the diameter of the outside one is 132 feet. Okay, that's in blue, so that's this whole all the way across. That's 132. Now, what about the inner rail? Okay, the diameter of the inner rail is, well, the radius of the inner rail is 64, so that's just 64 times 2. So that is 128 feet. Now, once we know the diameter, finding the circumference is very easy because it's pi times the diameter. So this would be 132 pi, and this would be 128 pi. So all that's left to do is subtract them. So when we subtract, we're going to get 4 pi, and that's going to be in feet. So that's how much further the wheel would travel. Now, put it in your calculator if you need a rounded off value, and we can round this off to the nearest tenth. It's 12.6 feet. Now we come to the last 3 examples. These have to do with area of circles and sectors. First, find the area of the circle in terms of pi, and for area, remember our formula for area, pi r squared sounds like area to me. So the diameter is given to be 20. So what we need to note is that the radius is 10 centimeters. Now that we've done that, we can just substitute in pi times 10 squared, and 10 squared is 100. So that's just 100 pi. And then this is area, so we're going to answer in square centimeters. When we squared the 10 centimeters times 10 centimeters is 100 square centimeters. So we have that squared. Now the last 2 examples. We're going to find the area of the shaded sector and leave our answer in terms of pi. So let's recall our formula for that. The area of a sector, well, we just need to find what fraction of the circle that it is and multiply it by the area of the whole circle. So x over 360 represents the fraction of the circle times the area of the entire circle, pi r squared. So just like we did on arc length, we're doing the x over 360, which in this case is 80 over 360. Now we have to know the radius. The radius is 9, so it's pi times 9 squared, pi r squared. So that gives me, well, I'm going to reduce this fraction. I just like to reduce that. Notice this, of course, it divides out by a factor of 10, and 8 over 36 would reduce to 2/9. And then the area of the whole circle is 81 pi. So it's pretty easy to simplify this also. We can just say 9 goes into 81 9 times. So my final answer is, in terms of pi, is going to be 18 pi square yards. Now, the last one is the same kind of problem, so let's write down our formula so we'll know what to substitute in. The area of a sector is the fraction of the circle that we're looking for, which is x over 360, times the area of the entire circle, pi r squared. So for this one, the area is, well, we've got to find that degree measure. Notice this is going to be 20 degrees because this is 20, because these two form a linear pair. Altogether, this is a semicircle. So that's the 180 minus 160. That's how I got that 20 right there. So the diameter is given to be 28, so I'm also going to need the radius. That's going to be half the diameter. That's 14. So now I have everything I need to substitute into my formula. 20 over 360 times pi times 14 squared. Okay, and that's going to give us 20 over 360 reduces to 1/18. So that little sliver of that circle is 1/18 of the circle. The whole circle is 14 squared times pi, which is 196 pi. Now, what I would do is I would just enter this fraction part in my calculator because that does not divide evenly. So if you put in the fraction 196 over 18 in your calculator, you're going to see that it reduces to 98 over 9. So it's 98 ninths pi, or you can put the pi in the numerator. Either way, it means the same thing. That's in square meters. So I hope these help you with your assignment. I know you're going to do great. I miss you, and it has been a great day to learn some geometry.